Now, when we're simplifying expressions, we might come across square roots or potentially cube roots. And I want to show you how we can simplify those types of expressions and how we can work with them. They can look quite scary at the outset. But what I want to show is that there's really nothing to fear. So let's start off with something like root 5 all squared. Okay, so square root of 5 all squared. Now, what we need to understand is that square rooting and squaring are inverse properties of one another. So if you had a function machine, okay, so if you put a number into a machine and you cranked a handle, and what the machine did was it square rooted the number and it brought out a value, you then put it through a second machine, you crank the handle and the second machine squares the number, then what you should get out the other side is the number that you originally put in the first machine. Okay, so what should happen is that it should go through one machine, it changes, it goes through a second machine, it changes back to what it originally was. So the two processes invert one another. So the square root of 5 all squared has to be the same as 5. Okay? Of course, you could see that as the square root of 5 times by the square root of 5. So it's recognizing that that is the same as 5. Okay? Now, essentially, behind the scenes, okay, and one way you can think about this, if you like, this is going a little bit further than we need to at this stage, is you can think of that as the square root of 5 times 5. These two things are the same. Okay, again, I'm going a little bit further than I need to, but if it helps you, that's great. 5 times 5 is 25. And of course, the square root of 25 is 5. Okay, we know 25 as one of our square numbers. So this has to be the same as root 25, which is 5. Now, another thing that we need to be able to deal with is things like if I had 3 root 5s and then I had another 4 root 5s. So an expression like this. Now, this can scare people off because it looks like two completely different things that I can't combine. But actually, it depends on how you say it. If you say, I've got 3 root 5s, and I add on another 4 root 5s, how many root 5s do I have? Well, if I've got 3 there and 4 there, I must have 7 root 5s. Okay? So, if I've got 3 elephants and I've got another 4 elephants, how many elephants have I got in total? I've got 7 elephants. Okay? So, it's the same idea. Essentially, this is underpinning what you see in the algebra section. Okay, so if I had 3x plus 4x, that's 7x. It's the same thing. Likewise, we can bring in a little bit of algebra here where we are expanding brackets. So we could be asked to do something like root 5 times by root 5 plus 2 and simplify that. So expand the brackets and simplify. Now, what happens is that you multiply the root 5 by the root 5 and the root 5 by the 2. So whatever term you have on the outside has to multiply with all of the terms inside. So everything needs to be multiplied by everything else, essentially. So you have the root 5 times the root 5, which we know is 5. And then you've got the root 5 times the 2. Well, how many root 5s do I have if I multiply it by 2? I've got 2 root 5. So this is the same thing as 5 plus 2 root 5. So all of these things that we're doing here It is bringing in a little bit of the algebra content of expanding brackets and collecting like terms. It is bringing in this understanding that a square root and a square, they are inverse processes of one another. So there's quite a few kind of ideas here that are lurking behind the scenes that we could go into in a lot more depth. But really at this stage it's being able to spot, oh, it's an expression that I can simplify and this is the way that it behaves.